Good evening, everyone. I'm Shylaja Ranganathan. I'm a data scientist. Today, I'll be presenting you our team project on optimizing healthcare resource allocation study using data science, machine learning. Global life expectancy has improved significantly in recent decades. It's around 73 years. It has increased by more than 6 years between 2000 and 2019. So, as the years progress, we see the average life expectancy they increases. You can see the chart where I have given the sample of uh, countries and the life expectancy. This is due to better access to healthcare, shorter hospital stays, and overall advancement in healthcare, which leads to longer and healthier life. In the healthcare industry, hospital and medical facilities, they invest in various equipment to enhance the patient care. This affects the length of patient stay in a hospital. As these investments influences hospital stays, patients experience reduced cost and hospitals can admit more individuals, expanding the access to healthcare. In our earlier Power BI report, our project seeks to analyze the relationship between healthcare investment from 1990 to 2018 and the impact on the length of hospital stays. Here, let me take an example of a location, Luxembourg. Here, you can see that in Luxembourg, as the hospital stay drops down by 1%, my MRI units, CT scanners, and hospital beds, they have an increase. Whereas for 2004, my hospital stay value decreases by 3%, but my MRI units, they drop down by 1%, CT scanners increase, and my hospital beds drop down by 1%. Now, our team thought, let's take this data further to data science to investigate which factors have stronger impact on the hospital stay. In an era where healthcare is vital, we are using this data science to understand how MRI unit increase or decrease, CT scanners and hospital beds fluctuations, they affect the hospital stays. Our goal is to create a predictive model to reduce the hospital stay and optimize resource allocation using data from various countries. We used 32 countries and their years. We are examining independent variables like MRI units, CT scanners, hospital beds, location, year, and their year over year changes of these CT scan, MRI, and hospital beds. These are all our independent variables, and we have our target variable as the hospital stay. Why we are doing this project? This is because we need to find how we can plan the resource allocation and mainly how the waiting time of the patient can be reduced so that more patients when they get in and they get discharged, then the hospital can accommodate the new patient. We have seen in our pandemic times how there was a crash in hospital sector, right? So this will be useful. Mainly cost efficiency plays a very important role. When we stay more for hospitals, the patient has to spend more dollars on it, right? Here, I have a table which shows the average cost of a hospital stay per capita in some countries worldwide in 2022. The actual cost of hospital stay varies depending on several factors like type of treatment, duration of stay, and location of the hospital. So we thought, let's move our project to next level, Microsoft Fabric. As we know, Microsoft Fabric is an all-in-one analytic solution that offers a comprehensive suite of services. We do a wide range of activities here, like we do data exploration, preparation, cleansing, experimenting our research, modeling, and training, and doing the prediction. Here, what we did is we created a workspace and we created a lake house for our project. And then we started off with our data science journey. This gives the outline of our project. First, we identified our business problem. What is our problem? We want to see how my independent variables, especially the healthcare investment, CT scan, MRI, hospital bed, how they are going to influence my hospital stay. Then, reading the data using the reading frame code, where we used several Python codes, we imported libraries here. Then we did the data cleansing. Data cleansing we did in transformation in Python. We also used the data wrangler. Then we trained our model using various algorithms. Then finally, we predicted using the best algorithm, which gives us prediction accuracy, better prediction accuracy. Now, what we did is in the coding, in transformation, here the codes are transformed in a notebook. The string value of a location is converted to mission language. As you can see here, the locations were the USA, Australia, but here my mission language is converted into zeros and ones. This we did in our transformation because the data which we got was not cleansed. So we used here. And you can see we imported pandas and libraries for these transformation purpose. Then we did some data cleansing in data wrangler. Data wrangler is like a transformation Power Query, like how we do Power Query transformation. It is similar to that. Here we did data cleansing. We used to convert our nulls to zeros in Wrangler. And then we used our Python codes to make the year-over-year values for the first location here as zero. When there is a first location here, ultimately your year-over-year value will be zero, right? So we did this transformation here. But here we observe that to use this data wrangler to replace null as zero, to access this, it is accessible only in Panda library. So we have to run the code in Pandas. Then after doing the transformation, then we trained our model. The data set which we have, we split it into training and testing, 80% testing and 20% training the model. Then we built a model to predict hospital efficiency using hospital stay as a target and importantly, MRI units, CT scan, and hospital beds as predictors. We tried various models like linear regression, gradient boosting, all, but the final result was achieved using random forest regressor, which gives us a value of 0.89, which is closer to 1. What is this random forest regressor? It is a machine language that is great at predicting the numbers. For example, if I want to go for a vacation, what I will do, I will ask my friends, can you suggest me a good place where the kids can be active, all that. Each of my friends will predict their own places, right? Then, depending on their choices, I will think which one will be executed, right? Based on their multiple choice, I will come to a prediction. The same logic is followed by this random forest regressor. It will split the data into smaller subset. Then it will have multiple data tree. Each of the decision tree will come to a conclusion, prediction. Then we take the average prediction values. Then after training the model, what we did, we need to find the relationship between the features, location, year, MRI units, CT scan, hospital beds, and year-over-year values, and how they are going to influence the hospital stay. Here we are more concerned on the hospital investment, CT scan, MRI, and hospital beds. We found this correlation plot where we found that whenever there is a dark color, it says that dark blue, it says it has a stronger influence. When it has a mild color, it says the influence is less. Whenever there is a red, it says there is no effect. So we break down this chart further for easy understanding. Here we found that the CT scanners have stronger impact on our hospital stay, followed by that MRI units and hospital beds. You can also see our scatter plot for the CT scanner, where increase in the CT scanners, they are affecting our hospital bed, hospital stay. So why we are doing this project? In our conclusion, this project seeks to provide valuable insights for hospital management and healthcare consultant. This will enable them to make data-driven decisions. It will help them to plan effective resource planning and patient flow management. While resource availability is essential, we need to balance the strike. We should not do overuse of diagnostic tests, and we should not increase the patient cost and unnecessary hospital stay. So, as I mentioned, efficient hospital system is essential to gift our future generation increase in longevity, offering them more quality time together and healthier. We are presenting them a happier world for it. Thank you.